good afternoon everybody. Please sit down. Thank you, sir. Okay, dear students, today I want to introduce our topic by doing something different. So one of you please come in the front. You boy, please come in the front. Here I have brought a ball today. Okay, pick it up. Okay, you come up. Okay, you please drop it once. Okay, once he has dropped. Another you please, you hit it. Hit it. Okay, throw it. There. Okay, you have seen that your friend is throwing the ball upward and hitting the ball in front of you. So from these two activities, can you guess what might be the topic that we are going to study today? Okay, you boys, thank you. Go and sit down. Can you guess, everyone? One might be the motion you are saying. Motion, yes? Okay, another please guess what might be the topic today? Okay, everyone. Sorry? Okay, this boys. We have guessed that the projectile. Okay, so others? Okay, let me write down. At first, I want to write down projectile motion. Okay, let me write the definition for this. Okay, you can note down. Motion of body under the effect of gravity alone. Okay, the ball thrown was under the motion and it was under the gravity. Okay, it was under the gravity because we are on the earth's surface and it has its gravity that is attracting force towards its center. So when the ball is thrown upward and thrown in front to the horizontal, it came down. That means it is due to the gravity. And this time, while we study the projectile motion, and this type of motion is known as projectile motion. The motion which is happening under the effect of gravity alone. Alone because other effects are neglected, not taken into account. Because there might be air resistance as well and some other type of friction. We do not include this in our calculation. That means while we study the projectile motion. Okay, did you got it? I mean, what type of motion fall into the projectile motion? You have some idea about this? Okay, if so, I've seen you sitting 3 there. You please, one of you write in your copy and other tell your friend the examples of projectile motion. That means the motions that is happening in front of you, which is under the effect of gravity alone. Write some examples that you know. You please, everyone, I have divided you into 3 groups. Please write down some examples. aspect you have written some examples. And let me start from the front. From the group, please, one of you, tell me the example. Okay, it's okay. You can have written a number of, you can see, tell me one example from each group. One example. Okay, from this group. Okay, Roshin, you see. What you have written from the group?
A cricketer hits the ball.
Okay, cricketer
Hit ball to get six.
hitting a ball to get sixes. Okay. Oh, this. Sit down, please. Thank you. Okay, next group. Manu, what have you done from the group? Okay. Throwing. Okay, these examples. Throwing stones. From top of the tower. Okay. Okay, and this group, what is your example? Okay, you go in, please.
Going with paper rocket.
Paper rocket. Okay. Going. Okay, sit down. The paper rocket. Okay. Some examples. Okay, thank you very much, everyone. Okay, so in order to understand these examples of these motions, these all are under the gravity. So this type of motion are known as projectile motion, and we can trace the path of this type of motion which are happening under gravity, and the path are known as the path of followed by the projectile is known as trajectory. Okay. The examples you have given, when the cricketer hits a ball to get sixes, the ball will go through the path, the motion will be under gravity, and that path is known as the trajectory. Okay. Everyone, in order to understand the projectile motion, we need to understand the velocity vector. Okay, the velocity vector can have two components, the vertical component and the horizontal component. Okay, the vertical and horizontal component, v velocity. The horizontal component is vx, the vertical component is vy, because the axis, vertical axis is y and horizontal axis is x. You know this. Okay, to understand these terms and to calculate the projectile motion, let us see some examples. Okay. Before this, let me ask you one question. That what does negative acceleration does to the velocity? Okay, let me write one question. What does negative acceleration does to the velocity? If the acceleration is negative, what will happen to the velocity? It increases or decreases? You guess? negative acceleration means retardation. What does retardation do to the moving body? Its velocity increases or decreases? Decreases. Isn't it? So, if acceleration is negative, then the velocity, what happens? It goes down, decreases. And we know the projectile motion. Okay, I need some space. Do you know about gravitational acceleration? It is denoted by what? G, and its value is negative 9.8 meter per second square. Gravitational acceleration is negative and it is 9.8 meter per second square. Okay, let us see what happens to the velocity of the body when it is okay, the ball is taken and it is dropped downward. Okay, when the ball is taken from certain height and it is dropped downward, the ball will be under the effect of gravity. And it will be under motion, that means it will have velocity. And we just know that velocity has components, x component and y component. But it seems that it is one-dimensional motion. So in which direction the ball is moving? X or y direction? It is moving in y direction. Yes? So what will be the velocity of y component? Velocity of y component will be significant, and what will be the velocity of x component? Vy is the motion of the body or velocity of the body, and what will be the Vx there? It will be 0, because while you drop a ball, then the motion will be vertical only along the y-axis only. The x-axis motion is, or horizontal motion is absent. Okay. So here we want to notice, okay, at time and velocity along y-axis and velocity along x-axis. Initially, at time t equals to 0 second, the vertical velocity is also 0. For example, the ball is dropped from rest, and the horizontal velocity is absent there, 0. Okay, it is moving under the effect of gravity. Therefore, for example, after 1 second, what will be its velocity along y-axis? Can you guess? Okay, good. It will be minus 9.8 meter per second. I have written the minus because look at here. If you go to the axis, x-axis, negative x-axis, y-axis, negative y-axis. Okay. So look at here. The motion along which axis? Along this negative axis. Therefore, the value will decrease. That means it will be negative 9.8. Because the gravitational acceleration is minus 9.8 meter per second square. That means the velocity will change at the rate of 9.8. Isn't it? So, if you go on 2 seconds, it will be minus 19.6. Third second, it will be minus 24. It is 29.4 seconds. Okay, you can go on sum up. Okay, for example, at t equals to 0, 1, this position, 1, 2. Okay, for example, in the third second, it will appear to the ground and strike with this velocity. Okay, what will be the original velocities at different time? Can you see? It will be 0. Okay, good. Because the motion is only under the vertical line, vertical axis. The horizontal motion is absent. Are you clear? Okay, this is one-dimensional motion under gravity. You can say this motion as the projectile motion as well. Okay, after this, everyone, I want to talk to you the projectile motion in 2 dimensions. Next. Dimension. Okay, previously you have given me the example, yes, from your group. So among the examples, which example will fit for the projectile in 2D? Who can 2D projectile motion 2D motion? Cricketer hitting a ball. Okay, nice. Okay, can you trace the trajectory? Can you imagine and trace the trajectory while a cricketer hits a ball and what happens to the ball? About its motion. Okay, individual, draw the trajectory in your copy and share within your friends nearer to you. Okay, I am giving some time to you. Trace the trajectory. Trace the trajectory for the motion of ball. Hitting by the motion of the ball. The cricketer hits it. Okay. Okay, have you done this? Okay, I expect you will check your trajectory. Okay, for example, I have the ball and it is heated, so that its trajectory will be like this. Okay, is this you have done? Stay up. क्रिकेटरले जब बल ब्याटले बललाई हिट गर्छ त्यो बल जाने बाटो. Okay, so you can see here the velocity. You can see here the velocity of the ball. V, let us suppose, and the angle is made with the horizontal by that ball. Let it be theta. Previously also we have known that the velocity vector has 2 components, rectangular components, the horizontal and the vertical component. Do you see the components there? Do you see? Your case ma huncha. Okay, so there will be the horizontal component of this vector and here you will have the vertical component. Okay, Vy and this is Vx. So what will be Vx? Vx will be V cos theta, and what will be Vy? Vy will be V sin theta. Okay. The component velocity can be V cos theta and V sin theta. Okay, are you clear in this? Okay, if so, here our aim is to see the change in velocity with respect to time when the body is under the effect of gravity, or the change in velocity of the projectile body or projectile motion. Okay, let me suppose that for this, initially the body is moving with velocity 90.6 meter per second. Okay, so let me see what happens. Vx, Vy. Okay, and here let me suppose that its vertical velocity is Vy equals to 90.6 meter per second, and its horizontal velocity Vx is 5 meter per second. Let me suppose, and let us look at what happens here. Okay, at t equals to 0 second, what will be Vx? Is it 0? Initial velocity. Is it 0 or not? Vx is along this axis and it has started with 5 meter per second. And Uy is along this direction and it has started with 19.6 meter per second. Okay, after 1 second, what will be the velocity of a body? For example, after 1 second, the body will be here. For example, this position A, position B. The body will be at position B after 1 second. So, what will be the horizontal velocity at B of a body after 1 second? What will be? Okay, think about the gravity. Think about the gravity or gravitational potential. Gravitational acceleration. It acts along horizontal or vertical direction. It is always along the vertical direction. What is the value of acceleration due to gravity in horizontal direction? It is always 0. Okay, good. You know. The value of acceleration due to gravity is 9.8 here along the vertical direction, and the value of acceleration due to gravity is 0 along horizontal direction. It does not act along horizontal. It acts along vertical. Okay. So, will there be effect of gravity along x-axis, horizontal direction? Yes or no? Then the velocity will be constant. So, what happens to the velocity along y direction? After 1 second, it becomes 9.8 meter per second. How we can say? Because the velocity is decreasing at the rate of 9.8. It is decreasing. Therefore, okay, after another second, the body will be here. So you have seen there, this velocity, horizontal velocity is 5 meter per second, and vertical is 9.8 meter per second. Okay, at point C. Can you say what is the Vx there and Vy there? Vx is 5 only. And what is Vy there? 0. It is 0. Oh, yes. 0. That means at the highest point, isn't it? This is maximum height. Highest point. Highest point, the velocity is 0, but the vertical velocity is 0. What about the horizontal velocity? It is still 5 meters per second. Now it starts to fall down. In another second, it will reach to this point, for example. Okay, this point. For example, the D. Okay, what will be the vertical and horizontal velocities?
5 meters per second.
Again 5 per second, not 5 meters per second, and it will be the velocity is decreasing minus 9 meters per second. Okay, look at here. The value is same at these 2 points. 9.8 here, again 9.8 here. The velocity is going like this. Yes, one direction, and the velocity is in another direction. That means the vector quantity. Velocity is a vector. Therefore, it is upward. It is plus. That means it is going downward. That means the sign is changed. Isn't it? The sign is changed. But the magnitude is same. You can see here. And similarly, if you go here in last second, the horizontal velocity will be same, and the velocity to the vertical will be 90.6 meters per second. Okay. So, while the body is under the motion of gravity in 2 dimensions, it will have 2 velocities along horizontal and vertical. The horizontal velocity is not affected by the gravity, whereas the vertical velocity is affected by the gravity. Isn't it? Are you clear in this? Okay. Okay. If so, let me go to next type again. In 2 dimensions, it is one of the type. It is the case projectile had at an angle with the horizontal. Isn't it this case? Isn't it? Projectile had at an angle. The projectile is had projected at an angle with the horizontal. Theta. Yeah. What are the conclusions in this case? It is moving under the gravity. It goes upward so that its vertical velocity at first goes on decreasing and becomes 0 at the maximum height. Isn't it? And then it starts to go down and its velocity goes on what? Negative sign. Goes on with negative sign. Isn't it? And over the motion, the horizontal velocity is always the same because the gravity does not affect the horizontal motion. It only affects the vertical motion. These all are to complete. Okay? Okay, from the example that I have written previously, you have given from the group, is there any other type of trajectory in your example? Trajectory यस्तो रहेछ हो, त्यो बाहेक अर्को खाले ट्र्याजेक्टरी भएको एक्जाम्पल छ त्यहाँ? Throwing a stone. Oh, throwing a stone from the. You have their example. Good. Okay. Again, your turn. You draw the trajectory in this case. I'm writing the case here. What is your case? Throwing the what? Please tell me. Throwing the stone from the top of the town. Okay, everyone, please draw the trajectory, possible trajectory in this case. Okay, I think we have drawn. Check your trajectory. Okay, look at the trajectory I have drawn here. Is it like this? Okay, good. The trajectory will be like this. So let us, again we are going to, because our aim is to, so look at the change in velocity of the body under gravity. Do you see these two motion, vertical and horizontal motion? The body will have two velocities again here, because it has started from here and the height has gained and some distance has also gained. Therefore, there are two motions we see there. Isn't it? So let us start with the Vx and Vy. At t equals 0, what will be Vx and what will be Vy? Can you tell me? Vx and Vy. At 0 second. Now, okay, 0 second, don't be confused. 0 second means the stopwatch has been started and the body has been released. For example, at this time, let the body is started with 5 meter per second away along the horizontal. यसरी फालेको छ नि हैन, यसरी फालेको छ, फाल्दाखेरि चाहिँ के भयो 5 meter per second मा फालेको छ for example. So what will be the horizontal velocity? Initial 5 meter per second, and what will be the vertical velocity in this case? But okay, look at here. This is going in this direction. At this time, the vertical motion, there is no vertical motion, therefore it is 0. Okay. Okay. After some time, for example, after 1 second, the body is here. So what will be the horizontal and vertical velocity? Vx, Vy. Sorry. What will be Vx? What will be Vx, please? What will be Vx? Are you guessing? Okay, you guess, please. What will be Vx, or you have understood? Because we are under the gravity, gravity acts only along the vertical direction, horizontal direction, motion in horizontal direction is not affected by gravity. That means along the Vx means horizontal motion. What will be there at point, for example, A, B. B भन्ने point मा. It is again 5 meter per second. And it will be, we know the gravitational potential minus 9.8 meter per second. Vertical. Similarly, second, for example, it will arrive here. What will be the horizontal velocity here? What is Vx? You know how the Vx कति Vy कति? Vx. What will be Vx? It is always the constant. Always constant. Yes? 5 meter per second. And what will be Vy? It will increase again. 90.6 meter per second. Ground मा आएर स्ट्राइक गर्दै बल खसालेको थियो नि हामीले तल गएर ठोकिराखेर चाहिँ के भयो त्यो केही भेलोसिटीले ठोकिन्छ नि त त्यहाँ भेलोसिटी नहुने भने त त्यहाँ ड्रप हुँदैन नि फेरि हो केही भेलोसिटीले त्यहाँ ड्रप हुन्छ त्यतिखेर के हुँदो रहेछ त यो भेलोसिटी के भन्छ इन्क्रिज भइराछ y डाइरेक्सनको भेलोसिटी इन्क्रिज भइराछ x को अलवेज कन्स्ट्यान्ट हुन्छ बिकज अफ होरिजोन्टल डाइरेक्सन इट इज अलवेज constant. The gravity does not affect along horizontal. The gravity is always along vertical direction. Okay. So what are the conclusions here? From this, can I write down the case? Your case को नाम क्या होगा? Projectile fire from certain height along the horizontal. सीधा फालेको छ यता हाइटमा गएर फालेको छ भन्ने केस यो भयो यो केसमा के हुँदो रहेछ द होरिजोन्टल भेलोसिटी is always constant and the vertical velocity is changing with negative sign. Because the body is coming in negative y direction, we can understand like this. Okay, I hope you have got something. I want to give some work for you to do it in group. यो जुन ग्रुप छ त्यो ग्रुपमा केही क्वेशनको आन्सर दिनुपर्ने हो के है, सकिन्छ होला? ओके, लेट मी राइट डाउन सम क्वेशन्स फर यु. Okay. Define projectile. And number 2. Write down one example of projectile motion and draw its trajectory. Okay, let me see how you do this. Two problems. You can do with your friends of your group. Discuss within your friend and write answer in one of your copy. Okay, I expect you have done the class activity I have given to you. Okay, I've done this complete. Finally, please, any queries on these topics that you are not getting? If you want to ask me something, please. Okay, if so, please, there I have given you 2 questions. I have written 2 questions to do at home. I expect you will do this because you have understood. Yes, you are not actually raising questions to me. That means you will be able to these 2 questions to me. Okay. From this, I want to end up the class. Thank you, everybody.
Thank you, sir.